In this project, I will demonstrate how to use Watchdog Timer in FPB-RA0E1 board. Open Escape Studio and create a new project by clicking on this file icon, then select New, then select Renesas C++, then select Renesas RA project. A new dialog box will appear. You can give name to your project here. After naming your project, click on this next button. Here from this drop-down menu, select FPB-RA0E1 board. After selection, click on next button. Here select executable and no autos option. Then click on next button. Here select bare metal minimal and click on finish. After project creation, IDE will open FSP configuration file. Now click on stack tab, then click on new stack, then select monitoring. Here select independent Watchdog timer stack. Click on this information icon to study FSP documentation related to independent watchdog timer. We can calculate the timeout period for independent watchdog timer using these calculations. Open FSP configuration file and click on BSP tab. Scroll down to find OFS register settings. Expand independent watchdog timer tab. Here you need to enable independent watchdog timer. Here you can select period counts according to your preference. Here you can select between NMI, interrupt and reset. I don't need to change anything here. Now click on generate project content and press proceed button. Now open halentry.c file under src folder. Now add Sagar RTT source code in your project. You can download and install JLink from Sagar website. Include commonutil.h file in halentry.c file. Commonutil.h file contains settings related to RTT. Now I will add two function prototypes, one for normal conditions and one for error condition. Now I will implement the error condition function call. Now I will define two variables, one for timer cycle counts, other one FSP error variable. After that, declare while one loop, then expand developer assistant tab. From developer assistant tab, drag and drop watchdog timer get counter function call in halentry.c file. In second argument of get counter function call, you need to provide the address of counter variable. After that, we can print counter value on RTT terminal. Now add a delay using RBSP software delay function call. Now I will implement function call for normal operations. In normal condition, define a timeout variable and then declare FSP error variable. Now I will define while one loop here with condition for timeout. Now I will use appprint function to log data on RTT terminal. After that, I will introduce a 5-second delay using RBSP software delay function call. After a long 5-second delay, I will reset the watchdog timer and then make the timeout condition false so we can return from while one loop. After that, application will enter error condition from which we will not recover and board will reset. In halentry function, you need to add this line according to FSP documentation. Now I will use appprint function to send system restarted message on RTT terminal. Now add a 3-second delay by using RBSP software delay function call. Now declare FSP error variable and from developer assistant tab drag and drop watchdog timer open function call in halentry function. Now use assert function to make sure watchdog timer open function call was successful. Here I will execute normal condition function. Use appprint function to indicate normal condition is executed successfully. Now system will enter in error condition and board will restart after watchdog timer reset the board. Now click on your project name, then click on this hammer icon to build your project. Now you need to find Sagar RTT address. You can find that in .elf file under binaries. Open .elf file and search for underscore Sagar RTT. You can copy Sagar RTT address from here. After that, right click on your project name, then select debug as, then select Renesas GDB hardware debugging. Now click on switch button to open debug perspective. Now you can use Sagar RTT address from .elf file to connect with RTT terminal. Now press resume button to start execution of the program. Here you can observe that after system is reset, it will start executing normal condition. After returning from normal condition, it will enter in error condition. There Watchdog timer will not be reset. Due to this error condition, Watchdog timer will reset the board after counting down to 0.